So we've taken a fairly, let's say, detailed overview of traditional retain count-based memory management, which is an option on OS X and required on iOS. But as you've mentioned several times during that, on OS X, well, at least from OS X Leopard onwards, we have another option called garbage collection. So where does that fit in?
Well, again, the Objective-C garbage collector is a pretty new addition to the language, only available on Mac OS X, Leopard, and newer. And essentially, it gives you the ability to not have to worry about all of the things that we just talked about in the previous section. Things like, retaining and releasing and auto-releasing. And for the most part, it gives you the ability also not to worry about memory leaks. If you don't do proper memory management under a retain counted model, of course, you'll have memory leaks. And so your application's memory usage will continue to grow and grow. And then before you know it, your computer will run out of memory and your application will crash.
So basically, a memory leak is where memory's getting allocated and never getting cleaned up.
Exactly. So garbage collection is a change to the Objective-C runtime so that the runtime itself keeps track of all of the references to all of the objects that you create. And it knows when an object is no longer being referred to in your application, and therefore it can be automatically collected, which is, it's marked as garbage, and so therefore it's collected up and released. So probably the first thing to talk about is, kind of the fundamentals of exactly how the garbage collector works. Any application that's written that is like a Cocoa application, one that has a GUI and a run loop, kind of like we were talking about earlier with regards to the auto release pool and so forth, will, assuming you enable garbage collection, will have a garbage collector thread running in the background. If, on the other hand, you're working with an application like we've been looking at so far, like Foundation console applications, right? You do need to manually start the Objective-C garbage collector. So just so that you know how to do that, although generally speaking, you're not really going to have to worry about this very much because most of the applications that are written today are going to be GUI applications. But if you were writing a Foundation application, like the ones that we've been doing, you would have to start the garbage collector thread manually. So to do that, you would call the Objective-C runtime method start collector thread. Okay?
Right, okay.
So once the collector thread is running in the background, essentially part of the run loop then becomes this opportunity for the collector to decide that you've sort of passed these thresholds of memory usage and it's time to go collect memory. And what it does at that point is it starts out at what are called root objects in your application. Now, root objects are basically defined to be global variables, stack variables, so in other words, variables on your current stack, and external references. It then looks at each one of those different references and walks through their object graph to any of the objects that they refer to as well. Once it's sort of mapped that out, then it looks at anything that wasn't referred to from one of these root objects, and it then it marks those as garbage and collects them. Does that make sense?
So basically, everything somewhere has to come back to something that's on the stack referring to it.
Right.
And so if it can't find it anywhere, it may be a reference of a reference of a reference, but if it can't find anything, it says, okay, you're finished with, you're going.
Exactly. So, for example, let's take a quick look at some code here. Here I've got an application it's actually a Cocoa application, and I imagine at some point MDN will probably have something specific to Cocoa. For now, I'm just using this as an example because that's probably going to be something that you're going to be working with is Cocoa applications. In this particular case, we are allocating this foo object as part of the application did finish launching. And the application, this is in the garbage collection app delegate, which is one of those root objects that we talked about. So because foo has a reference, actually that should be foo, because foo is a reference off of that root object, by allocating it here, it'll actually be marked as a valid reference. It won't be considered to be garbage. If, on the other hand, let's say that we actually weren't holding on to this here. Let's say that we didn't have that, and it wasn't a property of this particular object, and instead we were actually just holding on to this thing right here. In that case, because that reference is not being referred to from one of the global objects, then that will actually be collected once we exit this particular stack. Does that make sense?
Yeah, because I'm guessing the pointer object for foo, which is on the stack, when it goes out of scope, is going to disappear off the stack.
Right.
Therefore, the memory that was allocated for the object with the alloc_init no longer has a root object or something on the stack pointing to it. It can be garbage collected.
Right, exactly. So there's a couple of things to know. There's a couple of things that this impacts. First of all, when you enable garbage collection on a project, right, because of the fact that it's handling all of this stuff for you, the whole purpose of the dealloc method in a class is to give you an opportunity to release all of your member variables and to clean up your memory. Now, in a garbage collected environment, methods like retain, release, those kinds of methods don't do anything at all. Because there's no need to have these retain cycles and so on and so forth. So there's actually no reason to have an opportunity to call release on all of these things. And so therefore, your dealloc methods actually never get called. They're actually not used at all. Instead, in a garbage collected environment, they've actually introduced a new method called finalize.
Right, okay.
Now, the finalize method, so you might use finalize method in a way similar to how you're using your dealloc methods. Basically, it looks like something like that. And you would use finalize for cases where, for example, you have some kind of finite resource that you want to release and things like that. You would not use this for actually like releasing your member variables memory. Let's say, for example, that this guy had a file handle that it was holding open. You might actually, you might have a file handle that you would close in a method like this. That's kind of the purpose of finalize, is to handle those finite resources that you want to release. Now, there's a little bit of a caveat there, because the truth is, even using finalize, you don't know when the garbage collector is actually going to kick in. The finalize method will be called when your object is deallocated by the garbage collector. But because you don't know exactly when the garbage collector is actually going to do that, it's entirely possible that you could go quite a while without your finalize method being called. So you want to make sure, kind of using an example of a file handle may not be a great example, because a file handle is something that you could exhaust if you were creating a lot of these, right? And they were never getting the file handle was never getting closed because finalize wasn't being called.
Because the garbage collector may not cut in for minutes.
Exactly. And if you have, let's say you created, 100 of these objects that all open files, then those file handles, there's a finite number of file handles on your computer, and you wouldn't be able to, those would not be released. And so you don't want to do that. But the point is, if you have something that, not memory related, but that you used to do in your dealloc method that needs to still be done, something like, closing resources and things like that, finalize is the new place that you do that in a garbage collected environment. Cool?
Cool.
So Now, we talked a little bit about how the garbage collector goes through and it looks for references to objects from the root objects, right? The way that the garbage collector works is it goes through and it looks at what are called, well, there's two kinds of references. One of them is strong references, and the other is weak references. Now, by default in Objective-C, all references are strong references. And a strong reference, essentially, like I said, it's the strong references are the ones that the garbage collector will follow to make sure that those are connected to something. Now, a weak reference, on the other hand, is a reference which is considered by the garbage collector. It's a valid reference. You can assign it. You can treat it just like any other assignment. But if the object that is referenced by a weak reference has no other strong references to it from another root object someplace else, then the garbage collector considers that to be fair game to collect that object and set that reference for you to nil.
Okay.
Now, the interesting place that comes into play is in a part of Objective-C and a part of COCO called the NS Notification Center. Notifications are used when you want to send a notification from one part of your application to another part of your application. And what happens is you can register as an observer for notifications. And so you say, I want to register as an observer with the NS Notification Center, and then when these notifications come in, your application will be notified about them, right? So in those cases, the NS Notification Center actually uses weak references for your object that you're registering as an observer, so that you can kind of safely assume if I've deallocated myself, or if I no longer have any strong references to my object, I probably don't care about being notified about any notifications for that object anymore. So it uses weak references so that when my object goes away, as far as references from other places in my application, the NS Notification Center also says, oh, hey, that thing's going away. It can be cleaned up, and it's set to nil, which means if I need to, or if I try to send any notifications to it, nothing will happen because it's set to nil.
That's sort of really useful, because otherwise you're going to end up in one of these situations that, if notification centers were strong references, then the only reason your object is alive is because there is a notification center referencing it.
Exactly.
And the notification center only needs to care about telling you something because you're alive.
Exactly.
And so you create a situation where nothing goes away.
Right. And that would basically be sort of like a memory leak.
So by having a weak, things that are only interested you because you're alive, use a weak reference.
Exactly.
And then as soon as nothing that actually really is dependent on you is there, they'll all go away.
Right.
That's takes a little bit of thinking through, but that makes a lot of sense.
Right. So, like I said, the default for references is for them to be strong. If you have a situation like the NS Notification Center where you have an appropriate use for a weak reference, where, if you're not concerned about an object once it's been, basically it doesn't have any more strong references in the application, then you can also mark your references as weak references too. And you do that simply by using the underbar weak keyword when you are declaring the variable that will hold the reference to those objects. So just by doing that, that marks that reference as weak. And so if no other root objects have references that lead to that object elsewhere in your application, then the garbage collector, when it comes through, knows that it's safe to deallocate that object and set it to nil. Now, obviously, you wouldn't want to do that with things that you care about and that you want to keep around, but like in those particular specialized cases, that's okay to do. Now, for some of you who may be a little bit more experienced, you may be looking at that and thinking that maybe that's an appropriate place, or that an appropriate place to use that pattern is when you're implementing delegates in a garbage collected environment. A delegate, normally in a delegate pattern, when you're using like a retain counted memory management system, normally a delegate is set as assign rather than retain or copy, just because that's the the standard that you use because it avoids retain count loops. In other words, where I own the thing that I am delegating to, and so I set or the thing that I've created, and I set the delegate to myself. In which case, I'm holding on to it, and it's holding on to me, and you wind up with this cycle that never gets released. Right? We'll talk more about that when we talk about delegates. However, the garbage collector is actually able to detect those kinds of reference loops, and so you don't have to mark those as weak references. The garbage collector will automatically detect that and only release things when it knows that it can.
Okay, so when we come to talk about delegates later on, we can just assume the garbage collector understands them. If you haven't got a clue what delegate is at the moment, don't worry about it.
Right. Now, there's one other place that that the garbage collector, where weak references kind of come into play. There are specialized container classes. We've looked at NSArray. That's a container class. There's other container classes. We'll talk about container classes pretty soon. So there's NSArray, there's NSDictionary, there's NSSet, and stuff like that. And those all use strong references when you're adding items to them. Okay, so all of the things that you add to those will be kept as strong references. But again, there might be cases where you would rather have a collection that contains weak references. And there are classes that give you that capability. Those are the NSMapTable class, the NSHashTable class, and the NSPointerArray class. Each one of these, we'll talk about collections, but I just wanted to point out that those actually use weak references. And so when an object is deallocated that's in one of those containers, it'll be deallocated as well, and it'll be removed from the array, and it'll be set to nil. So now the last thing, so basically that's kind of how the garbage collector works, right? We talked about the fact that retain won't get used anymore.
So it can still be in your code, it just get ignored.
Right, it'll just be ignored. You can leave it there. You could even have the same code that's reused both in a garbage collected environment and a non-garbage collected environment, and just compiled with garbage collection on and off. It won't hurt anything to keep those methods there. And in fact, if you're an old school coder and you just love having retains sprinkled through your code, it won't hurt anything, so go for it.
Right, so the same code could be used in both environments, but I guess the only thing is you need to make sure that your classes have dealloc and finalize, if necessary, methods.
Yes, exactly. So like I said, we've talked about, kind of the impact. So retain, release aren't going to be used anymore. Dealloc is no longer going to be called, and you do have to have a finalize method if you need it to release any resources. So let's just take a quick look at how we actually configure a project for garbage collection. Essentially, it's really simple. You just go into your project's build settings, and you pull up, if you just type in garbage collection in the search box for the build settings, then you can come down here and you can see Objective-C garbage collection. And this actually has 3 different settings. The first one is unsupported, which basically means that you're opting in for a retain count memory management system. The second one is supported. Now that's usually used for libraries, and what's going to happen there is it'll actually generate code that can be used in either a garbage collected or a non-garbage collected environment, depending on how or on the application that the code is linked with. And then finally, if you are actually creating an application with garbage collection, then you would typically choose required, which is actually, it will turn on the garbage collector for you. And it will also, when you go to link with any libraries, it'll make sure that those libraries actually support garbage collection. Because if they don't, then you can't link with them. You have to then work only with frameworks and libraries that do support garbage collection.
So the default when we create new projects in Xcode is unsupported.
Yes.
So garbage collection is opt-in.
Correct.
Okay.
So that's pretty much the gist of garbage collection. There are some garbage collection patterns that are probably a good idea to review, and we'll go over those in the next section. But that's pretty much all that there is to enabling garbage collection in your applications.
So really, it's a little bit of knowledge to understand that you don't need things, and set one switch.
Exactly.
And you're done.
Very straightforward.
And great. But we'll learn about these patterns when we come back.